And today, graphs for sine and cosine. Okay, that's what we're going to focus on the rest of the week. Your gold sheet has us doing this yesterday. Obviously, we're doing this today. Everything from the 17th on needs to be bumped down a day. I'm not going to make new copies of our schedule just because we had one ice day. Okay, just bump everything back a day. So our quiz is really going to be on the block day. For you, it will be, is this fifth grade? Like your quiz will be Wednesday instead of Tuesday, kind of thing. Okay, of next week. So here is the unit circle. We are going to construct the graph of y equals sine of x. You don't need to write anything down right now. You're going to relax. Okay? Sine comes from which coordinate on the y coordinate? So at 0, sine is 0. And then we rotate to pi over 6, it's 1/2. Pi over 4, it's radical 2 over 2. Pi over 3, it's radical 3 over 2. And then all the way to 1. So what happens between 0 and pi over 2 is we increase until we get to 1. And then what happens to our y coordinates as we rotate to pi? They, in the same pattern, they go back down to 0, right? Then as we rotate to 3 pi over 2, we go in the negative direction with those values until we hit -1. And then we have some symmetry, right? We follow that same pattern back up to 0. Okay. I'm going to give you a little animation here. Okay. Here, this animation is going around the unit circle, and it's taking all of those y values and plotting them here on this graph. So at 0, we're at 0. At pi over 2, we're at 1. At pi, we're at 0. At 3 pi over 2, it hits -1. And at 2 pi, it's back to 0. Okay? This, ladies and gentlemen, is the graph of y equals sine of x. Okay? What's going to happen as it keeps going around and around and around? It's going to repeat. So this pattern is going to go on forever. Okay? But we're going to focus on just a chunk of the graph. Okay? We're not going to graph an infinite graph, right? Okay. So I would like you to go ahead and draw this in your notes. Y equals sine of x, and then I'd like you to make this red graph here. So we're going to come back and talk about this chunk of the graph, but notice how this is going to continue on forever. Okay. We're going to have some vocabulary words that will relate to the shape of the graph and the length and the height and all of those sorts of things. But just having this general shape to refer back to would be good. Okay. So we're 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. We're going to do the same thing now, but for cosine. Okay. Do you think that there are going to be any similarities with the graph of cosine and the graph of sine? Maybe? think no. Okay, so once again, take a break. Y equals cosine x. We're going to go around and look at which values now. The x values. So at 0, cosine starts at 1, right? And then we go, as we rotate, those values get smaller until at pi over 2 we hit 0. And then our values continue to decrease until at pi we're at -1. Okay? And then our values increase up to 0, and then in the same pattern back up to 1. So what happens is cosine starts at 1, decreases all the way to -1, and increases back up to 1. Okay, let's look at what that looks like on our animation here. So if I scroll down. Okay, here is our cosine curve. As we go along the unit circle, here we start at 0, cosine's 1, at pi over 2, cosine 0, at pi, cosine is -1, at 3 pi over 2, cosine is 0, and at 2 pi, we're back to 1. Okay, so this is our cosine curve. So go ahead and draw that red graph, y equals cosine of x, and draw those side poles. Are they similar? Similar, but not the same. These graphs are cyclic. Pretty soon you'll understand what I mean when I say periodic, but they repeat over and over and over and over and over. We have this little valley, if you will, over and over and over. As we keep rotating and rotating around the unit circle, we get the same value, so it's going to repeat, repeat, repeat. Okay, so we see that sine and cosine both kind of look like waves, right? Sound waves, maybe. Okay. If you're thinking of why are we even talking about this, okay? Sound waves look like this. But they're consistent and they repeat over and over and over again. Okay? What we're going to focus on today are identifying 3 things about our curve. And so that tomorrow we can focus on how to graph a curve that has been transformed. If it's not just y equals sine of x or y equals cosine of x. Okay? So we're going to talk about 3 things. What I'd like you to go ahead and do before we go to lunch is write down. Nope, I don't want you to do that. Sorry, I thought it was a different one. We'll go ahead and go through all the vocabulary after lunch. Okay? Great. It's Wednesday. Oh. Two vocabulary words that you need to know. The first one is amplitude. What does that make you think of?
Waves.
Okay, music. Yes. What do you say?
Waves.
It's for waves and how tall the waves are. Okay? We have sine and cosine waves, if you will. Amplitude is referring to how tall they are. Okay? Now, the amplitude is only half of the vertical distance. Okay? So if we take the highest point and the lowest point and we count up that distance, if we cut it in half, that is our amplitude. Okay? When we draw these graphs, we're going to start kind of from the middle. We're going to go up the amplitude and we're going to go down the amplitude to make our full wave. Our parent graphs, sine and cosine, have the same amplitude. If you look at those graphs that you drew, what is the amplitude for sine and cosine, their parent functions? It's 1, okay? Highest to lowest point is 2, so our amplitude is 1. I like to think of it as, you know, in this case, from the x-axis, we're up 1, from the x-axis, we're down. Okay, we have an amplitude of 1. We're not always going to be at the x-axis, though, so that's not a way to think of it. Okay? So vertical distance cut in half. Okay? Now, we also have the period of the function. So amplitude is measuring our wave height. Period is going to measure what? The length. Okay? Now, these waves repeat over and over and over and over again. So the period is the length of a unique piece. Okay? So it's the horizontal distance from a point on the graph to a point on the graph where it begins to repeat itself. So when I had those graphs up on the board, the red piece was just one period of the graph. Okay, and that's what I had you copy down. Some of you may have drawn the rest of it, but the red highlighted piece was one period of the graph. I'm going to flash back to that very quickly. I'll come back. What is the length of the period for y equals cosine? 2 pi. Where it starts to where it begins to repeat is 2 pi. That is the same for sine. We make a wave, here it starts to repeat, so it has a period of 2 pi. Anybody need more words on that page? All right. Now what I'd like you to write down are these two things right here. Okay? I'm not always going to give you y equals cosine x, y equals sine x. Okay? Sometimes we are going to have shifts and transformations that are going to affect our graph. Okay? So if you write these down, I'm going to tell you what they're going to affect and what we are going to identify. Okay? We need to identify 4 pieces in order to be able to graph these functions tomorrow. Okay, so let's think back to chapter 1. Oh, chapter. A is a number being multiplied to the outside of our function. What does that typically affect? Or how does that typically affect a function? Huh? Like x? Okay, what kind of stretch? Vertical? If it's on the outside, things get affected vertical. Okay, so A is giving us like a vertical stretch or shrink. What's that going to affect? Out of the 2 words we just put, it's going to affect the amplitude. Good news, A is the amplitude. Really the absolute value of A. We can't have negative amplitude. Okay? A is just going to give you your amplitude. So we're going to take the absolute value of A for your amplitude. What if it's negative? What does that mean? Okay, think of another way to describe that. Like x squared versus negative x squared. What happens there? Okay, it's reflected. That's the word I was trying to get you to say. Okay, and negative A is just going to mean that we have a reflection about the x-axis. Amplitude is never negative. Okay? The negative is just going to affect which direction the graph is going to be in. Okay? Now, for sine and cosine, the period for the parent function is 2 pi. Well, if we have this b multiplied to x, okay, that's going to be what kind of stretch or shrink? Horizontal stretch, okay? So that's going to affect the period, right? So, a simple way to determine how this is stretching or shrinking, since the parent function has a period of 2 pi, all we have to do is take 2 pi divided by b, and that'll give us our period. So we have amplitude and we have period. That gives us the size of our graph. The third piece, I guess, yeah, the third piece, is where we're going to start our graph. Okay? And really, this should be our fourth piece. I should have began by saying you need to determine whether it's sine or cosine, and you have to determine that shape. And that's what we're going to focus on tomorrow. Okay? So we have amplitude, we have period, now we're going to have starting points. Okay? The starting point, the x-coordinate is c over b, and the y-coordinate is d. Okay? If you remember back to our shifts and transformations, if there is something multiplied to x, then it also affects that vertical or that horizontal shift. Okay, so this is accounting for if there's any sort of horizontal stretch or shrink that affects the shift left or right. Okay, and then D, that is your vertical shift. Okay, so that should be an easy one, so I did it. Okay, this is what we're going to work on today. Okay, amplitude, period, and starting point. Okay. I am not sure if your book actually asks you to identify starting point, but for the problems today that I assign you, you are going to find starting point. That is going to help us tomorrow for when we do the framing method, okay, to actually make these graphs. All right? So let's do some examples. We're going to start off very simple. Okay, please write down y equals 4 sine of x. Four, that is where A is, right? A is 4. So what does that tell us? Our amplitude is 4. Okay. What is our B value? What is that coefficient of x? 1, okay? This is when it's nice, okay? So for the period, we take 2 pi divided by b. Well, in this case, b is 1. So our period is 2 pi. Is there a vertical or horizontal shift? There is not. There is nothing added or subtracted to x inside. There is nothing added or subtracted outside of our function. So our starting point, I am just going to label it as SP, so we don't have to write a lot of letters up here, is 0, 0. I wanted to do a simple example so you can see. Okay, if the starting point does not change, okay, it's gonna look like that. Let's do another simple example. Our A is -3. However, what do we say our amplitude is? Okay, it's the absolute value. So our amplitude is really 3. Okay? If you have a -A, make a note to yourself that the graph is going to be reflected. Okay? So our amplitude is 3, but since it's a negative A value, we're going to have a reflected graph. That will help us tomorrow when we actually go to graph these. Okay. All right, Will, what's our B value? 2. Our B value is 2. So to find our period, we take 2 pi divided by B. Okay. So our period in this case is pi. And once again, we don't have anything added or subtracted inside. We don't have anything added or subtracted on the outside. So our starting point is 0, 0. We don't have any shifts. Okay. Now let's step it up a notch. Are you ready? Of course you're ready. Trained you for this. Go ahead and write this down. Ryan, what's our amplitude? Our amplitude is 2. Good. Kelsey, what's our B value? 2. So to find our period, we're going to take 2 pi divided by B. So our period is length pi. Now our starting point. Remember that our starting point is C divided by B, comma D. Okay? Go back and look at the 2 equations I had you write down. What is inside the parentheses for sine and cosine? Bx what? Minus C. It's Bx minus C. So in this case, when we are finding C divided by B, what is our C value? Okay, our C value is pi over 3. Okay, when we shift left or right, remember things are kind of backwards than what the sign value appears. So if we are subtracting C, that is when it's to the right. Okay, so this minus pi over 3 means our C is pi over 3. Okay, and then we have to divide it by 2. Remember, dividing by 2, if you need to write it out, dividing by 2 is the same thing as multiplying by 1/2. So our x coordinate for our starting point is pi over 6. Okay, now what is our vertical shift? Okay, so then our y coordinate is going to be -2. So tomorrow, we're going to start our frame, is what we're going to do tomorrow. And don't worry about what a frame is, okay? We're going to start at pi over 6, -2, and then we're going to draw a cosine curve with an amplitude of 2 and a period of pi. Okay, one more example with me, and then I'll give you one to do on your own. This one's fun. Molly, what is our amplitude? 1. Good. Thank you for saying a positive 1. Now, A is negative, so make a note to yourself that we do have a reflected graph. So instead of our sign going up first, it would go down first. Okay, and we'll talk about more of that tomorrow. Okay. The period of this graph. Gabe, how do we find it? 2 pi over b. And what is our b value? 1/2. If we take 2 pi and divide it by 1/2, what does that give us? 4 pi. If you need to actually write it out, 2 pi times the reciprocal, okay, we get a period of 4 pi. So this is a very stretched out graph. All right, now for the starting point. And I'm going to probably do it. We need to find c over b for our x coordinate. Kelsey, what is the c value? Pi over 4, she said. Why did you change it to negative pi over 4? Okay, remember we have bx minus c. So in this case, we have a negative pi over 4 for our c value. We have a shift to the left. And our b value is 1/2. Oh my. Okay, do not panic. You guys are great at fractions, and these are very simple fractions. Okay, we have pi over 4 multiplied to the reciprocal of 1/2. So negative pi over 2 is the x coordinate. So our starting point is at negative pi over 2, comma. What's our y coordinate? Everybody all together? Oh, that was pretty easy. Okay. I am going to put an example up here that I want you to do without me guiding you. Okay. Do you have a question? Nope? Okay. Start with that one. Hannah, what is your amplitude?
1.
Good. Gabby, what's the period?
2.
Great. And our starting point, let's see. Sid, what's your starting point?
Pi over 4
Do you agree with all of those values? Now, I have another example, but we don't really have time. This is your homework. Your homework will feel very easy compared to the examples that we just went through. Okay? I more prepared you for tomorrow. Now, the first set of problems is asking for the period and amplitude. The starting point is at 0, 0 for the 5 through 16 that you're going to have to do. Then when you get through to the 19 to 29, you're going to have to like compare and contrast. So you'll actually have to say, well, this one has a starting point of this, but this one has a starting point of this. Okay, so you'll compare and contrast what's same and different. Okay. Tomorrow we'll really get into the meat and potatoes of graphing. Okay, I'll give you a little handout to help you, and we'll actually